So there is no pointer here, but I'll try to survive without it. Okay, so in the presentation today, we are going to talk about the software under development here at IDC. This software is called SCT, and SCT stands for Spot Check Tool. SCT is basically an implementation of some ideas described about 10 years ago in a paper by Bobrov, Kitov, and Lasina Zerbo. This paper is called Perspectives of Cross-Correlation in Seismic Monitoring at the International Data Center. So what we have 10 years from now. The idea of IDC Spot Check is this. We attempt to recreate events from some of the IDC bulletins, such as CEL3, REP, or LEB. We use cross-correlation technique to do so. Now it's a complex statement, but I'll try to explain it. If the event obtained as a result of cross-correlation procedure is not similar to the original IDC event in magnitude, in high percent allocation, or in timing, then the independent reviewer or the lead analyst obtains an additional information, which then can be used to figure out what's wrong. That's the idea. So if the results which we are getting through cross-correlation are very similar, then everything is fine with our original bulletin. If it's not, then the question is why, and this question can be solved by the independent reviewer. So this presentation has three authors. Dr. Ivan Kitov is actually the creator of the whole backend, the designer, the developer, the author of most of the papers. I am and my colleague Alexander Sukhotsky are contractors. So we are developing software here, and Alexander developed the graphical front end, and I worked on the integration of the whole package. So this is the first slide here. So let's formally define the spot check. The spot check is the final level of the interactive review procedure, which is aimed at the improvement of the quality of the IDC bulletin. So spot check tool software is based on the idea that the waveform cross-correlation can be used for signal detection and phase identification. In SCT software, which we are talking about, we cross-correlate waveforms around arrival times of events from IDC bulletins. We cross-correlate with the templates obtained from pre-selected list of master event. The current list is about 20,000 master events. Indeed, we are using historical REB events, reviewed event bulletins, as master events. We can also use fully synthetic or semi-synthetic master events if we want. Now, next idea is that cross-correlation event building procedure follows the IDC event definition criteria. And this following of the event definition criteria allows us to say that our cross-correlation is useful for spot checking. So now, in a perfect world, if one list, IDC, REB, and our cross-correlation Excel bulletin are the same, then everything is perfect. Unfortunately, our world is far from perfect, and so there are a lot of differences, and these differences are providing the food for thoughts and help in solving the problems with REB, LEB, etc., etc. So now, looking at the slide, finally. On the right, there is an image. Again, I cannot point on it. On the right, there is an image, and the green dot with the green circle is the REB event close to the Korean nuclear test, which happened on February 6, 2022. So then the yellow dot with the yellow circle around it is the master event. And this master event is actually the huge nuclear explosion which happened in 2016. Using that as a master event and doing cross-correlation with the data, we obtained this red dot. And this red dot actually moved the epicenter of the event about 20 kilometers closer to the actual test site. So IDC REB obtained something, and it's in the vicinity of the nuclear test site, but cross-correlation shows that there is a chance that the event actually happened much closer, and that is useful information, in my opinion. So let's move to the third slide. So this is the objectives of the study, and they are listed here because somebody can probably read this text in the future, but we kind of cover these objectives during the talk. I just want to highlight the last one. The last one is that SCT tool assists expert technical analysis and special study in addition to review officer, in addition to the analyst. We will talk about special studies a little bit later. So now, what we have here. So similar to IDC operational pipeline, cross-correlation procedure has three major stages. First one is waveform cross-correlation procedure, which actually replaces the operational detection and phase identification steps. Now, at IDC, those steps are implemented by the program DFX and the programs StayPro. And now these programs in cross-correlation pipeline are replaced with cross-correlation algorithm. Now, the global associator is replaced with local associator because there is no need to associate globally. We are only associating in the vicinity of the existing operational bulletins. And operational JA conflict resolution is also replaced with the modified one. Here in the slide you can see, some explanation of how the algorithm works. We don't have time to discuss it longer. So now it's important to mention that cross-correlation pipeline can be proactive and reactive. And when we are saying proactive is that we don't need any information at all about the other bulletins. We can really create a cross-correlation bulletin just based on the waveform data and templates from master events. While if we are working in reactive mode, this is spot check. We are using existing bulletins, and we are comparing our bulletin with the existing, and we are basing our cross-correlation work on the locations and timing of the existing events. We're taking some particular data waveform intervals and some only those master events which match the particular template criteria. So now this is, it's very difficult without pointing, but this is the diagram of how things work. All we see that from here you can see that we start with the existing bulletins. So we do this cross-correlation, then we have some options of matching the event, not matching the event, rejecting the event. From this we are creating this Excel bulletin, and this is going on. The processing happens day after day on daily basis. So after day 3 or 4 we have the bulletin similar to cell 3. After the day 20 we already have the bulletin similar to REB. And now we switch to the second part, which is interactive spot check. So what's the difference between automatic and interactive spot check? Interactive spot check allows you to visualize the results of the automatic spot check and to reprocess the data with your own parameters. That's two important things. So if you see at this screen, this is the event selection screen. There are small green flags. Those green flags indicate that for the particular event ID of IDC bulletin, there is an information about cross-correlation results. So you click on it, and you see the REB result or cell3 result, and you get the cross-correlation event location as well. So you can compare, and you can say, okay, so our cross-correlation is different or similar to REB. If you're not happy with this, then you really start using the facility of interactive SCT software more. That is, you work on the selection of those operational bulletin events which you care about. Usually it's a small number. Right now we are allowing only 10 events in interactive processing because it's kind of slow processing. Then basically you have this screen where you can define dozens of parameters of processing. In automatic mode, all processing is done using a predefined set of parameters. You want to change something, you go and then you run your processing for many, many hours. Here it's different. You can go and you change so basically the list of the parameters which we are having here is cross-correlation, detection, association. So that's these steps which are typical for any processing pipeline. So over here, this slide basically shows some of the features of our parameter definition screen. How much time do I have? Okay, so on the left here is the main screen of the program. In the main screen of the program, you have a list of all processing which has previously done. You can always look at the results. The right screen is the screen which shows the result of the processing for one particular event. I think I forgot which one I did here. So I just took something random over here. As you can see again, so the green circle here is the REB event, while it's actually the same thing. Yeah, I discussed it. I thought I had something different. Okay, so let's now switch to the guts of the software. So the interesting thing here is that we are using the existing facility, which is SWP portal, which exists for many, many years in IDC. So swp.ctbto.org is a collection of useful web applications, and we are just adding one more here. So the SWP portal is based on so-called LifeRay portal software. That's called also enterprise software, and it has a lot of features. For example, using LifeRay, we can easily create authentication of users and user roles, because that's already coming for free through LifeRay. Also, look and feel of the software is kind of governed by SWP. So we are just inserting one more application in CTBTO set of existing applications. So what's interesting about this? So if you see, the LifeRay has user interface, services, and core, and our software also follows this model when the user interface is our GUI portlet of the portal, and services are node and parameter selection, and then there is the core of this. These things kind of work independently. And they are working through JSON text files. So, so the core is actually generating whatever it wants. Then the small software, which is in the middleware, is actually converting the output of the core into this JSON format. And the front end understands JSON. And it's kind of easy to replace the core. And it's kind of easy to create this small application which converts the output of the other backend into JSON. And the front end is kind of dumb from front end. It doesn't understand much, but it's able to read this JSON. And in JSON, it's written everything. JSON is very simple. You see over here, we define the parameters. So the parameters here are defined by several records in the JSON file: name, type, key. Is this required or not required? And just processing this JSON file, the front end creates pretty meaningful and reasonably clear graphical user interface for the user. So on the left, the JSON; on the right, there is the resultant GUI. For example, you say that this parameter is always required. It's true. It means that if this parameter is not filled, then there will be an automatic error message. So it's pretty easy for the user. I think it probably takes a couple of hours for anybody to learn how to program this. It's not even programming, just writing the text file in the particular format. So, and eventually, when we are talking about expert technical analysis special studies, I think that could be used as the way of bringing in the software. Let's say a state party comes and they're saying, we want to process this particular data set using this particular piece of software. Sure, bring us the software, explain what's the output of this. We will convert the output into JSON, and our GUI will immediately show you the output. And if you tell us what kind of parameters you care about, we will add these parameters to the GUI, and the look and feel of the system will be very similar, and it will be the CTBTO IDC software which is running somebody's algorithm. I think that it might be useful. So now let's switch to the conclusions. They're here. Spot check tool is capable to facilitate the work of the independent reviewer and the broader community of customers, in particular analysts and NDCs. So automatic SCT software generates daily cross-correlation events and conducts comparison with cell and rep bulletins. That works right now. As we are talking, the computer is running. Interactive web-based front end of the SCT, on one hand, makes available visualization of these results of automatic. On the other hand, allows you to drill deeper and to obtain new runs by changing the set of the parameters. And SCT tool assists expert technical analysis of special study, or let's say it can do it now with our particular algorithm, but it can also do with the other algorithms, as I discussed. And interactive SCT tool can be considered a prototype of rapid development tool for special studies and ETA. Thank you very much.